Okay, now let's do another example. So if you have a pipe like this, okay, so and then force acting in this direction, okay. So this time it is given that the pipe is a distance and then the force, so you have distance and force, okay. There are two vectors basically, okay. So the first vector should have its own Cartesian vector, and then the force here also should have its own Cartesian system. But this time the F is not in the Cartesian form, it's given in a magnitude form, which is 100 Newton. So it is needed to change this form, this magnitude form, into Cartesian vector forms. So then you can do the dot product to get the projected component of force C to B. So here the step, you need to get the RCD and RCB. Here this is the RCB, and you need to also create the radius here, the vector position for this force, and then from the radius or the vector position, get the unit vector for those CD and CB. Okay, using that unit vector you can get the FCB. Okay. Okay guys, the question asks you to get the projected force of FCD. So the projected force of FCD is FCB. Okay, simply using this formula, if you know the theta here, okay, so using the cosine rule, here is FCB and then here is FCD. The cosine rules means that FCB per FCD, sorry, FCD, don't look this first, okay, FCB and F per FCD equals to cos theta. Okay, so you need to get the theta. Okay, first of all, you need to find the FCB and then find the FCD. Okay, so to find the FCB, FCD, so if you want to find the FCB, so you need to move the FCD to the other side, which means FCB is equal to FCD cos theta. So FCD is 100 Newton, it is given. So your task is to find the theta. So formula for theta, before this we learn, it is cos theta is equal to this is unit vector, okay, the up here is a vector, down here is a magnitude. So the vector is for FCD, vector FCD for in a Cartesian form, RCB in a Cartesian form. So if you remember Cartesian form, if you want to multiply with Cartesian form, we use the dot product. Okay, and then down here is a magnitude for FCD and magnitude for RCB. So you need to find RCB in Cartesian form and then FCD Cartesian form, number 1, number 2, and then number 3, F or RCB in scalar magnitude form. Oh, this is Cartesian vector form, Cartesian vector form. So these two is vector, and then number 4 is FCD, scalar magnitude form. So this 2 is magnitude. Okay, so first we're going to get the RCB in Cartesian form. So how we do it? Still remember the vector position. So vector position is RCB equal to x minus xb minus xci plus yb minus ycj plus zb minus zck. Okay, so this will give you a Cartesian form vector for RCB. So first, what is xb, yb and zb, and what is xc, yc and zc? Okay, so you need to find the coordinate first, the coordinate for B and coordinate for C. So the coordinate for B, I already write down here. So coordinate for B for x, y, z. B is here, in the picture is here. It is in the origin, so the coordinate is 0, 0, 0. Okay, and then coordinate for C, x, y, z. So x is in this direction, which is 0.6, and then y, coordinate for y is 0.4, and then coordinate for z is down here, 0.2. so because it is downward, so the direction is negative. And then you also will need to define the coordinate for D. So the coordinate for D is in x direction is 0, because they not move on the x direction. So for y coordinate is 1.2, and then for z also 0. Sorry, the z is 0. Okay, so if you want to get the RCB, vector position of CB or radius, we can write here R, vector position for this one, CB, R. So we can write like this, R CB is equal to XB minus XC I plus YB minus YC J plus ZB minus ZC K. So just substitute using those coordinate here. So what is XB? XB is 0 minus XC 0.6 I plus 0 minus 0.4 J plus 0 minus -2. Okay, so this you will get the Cartesian vector for RCB is -0.6 I minus 0.4 J plus 0.2 K meter. Okay, this is a vector. So for magnitude for RCB, as usual, RCB, so you need to square and square root 0.6 squared, 0.8 squared plus 0.2 squared. So you will get 1.02 meter. Okay, so you already get the Cartesian vector form for RCB, which is this one. Okay, this one, and then the magnitude scalar form for RCB, which is this one. Okay, next is to determine the Cartesian vector form for FCD. the one is given is in the magnitude form. Okay, and then okay, to change the scalar magnitude of f equal to 100 into the Cartesian vector forms, you can use this formula. Magnitude you multiply with the unit vector UCD. FCD you multiply with the UCD. So unit vector UCD, it is equal to the, you can use the vector position for CD, vector position for this CD, C to D, which is RCD. So unit vector is equal to RCD in a vector Cartesian form, and then divide by RCD in a magnitude form. So to get the RCD in a vector Cartesian form, so you need to do the same thing as you want to find the RCB. Okay, so RCD is equal to XCD minus XC plus YD minus YC plus ZD minus ZC. Okay, coordinate for D and C you already know, so you already defined here. Okay, so just substitute and you will get the Cartesian vector form for RCD is equal to negative 0.6i plus 0.8j plus 0.2k. Okay, so this is your Cartesian vector form for RCD. So for magnitude, RCD is equal to 0.6 squared plus 0.8 squared plus 0.2 squared. This is equal to 0.75 meter. Okay, so UCD is 0.575 meter. Okay, so UCD is equal to the vector form, the vector in Cartesian form, which is 0.6i plus 0.8j plus 0.2k divided by the magnitude 0.75. This is equal to, the UCD is a what is it, 0.588i plus 0.784j plus 0.17196k. Okay, okay, sorry, this is not 0.75, this is 1.02. okay, so this one is 1.02. okay, so after you get the unit vector, you can multiply with the scalar magnitude of FCD, which is 100. So you will get FCD in the Cartesian vector form. So FCD in a Cartesian vector form is equal to 100 multiply with negative 0.588, okay, I plus 100 0.78j, sorry, then plus 100 0.196k. okay, so you will get the FCD in Cartesian vector form, negative 58.8i plus 78.4j plus 19.6k Newton. Okay, so now you have the FCD in Cartesian form. So let's look at the formula here. So your aim is to get the theta, right? So using this formula, FCD in Cartesian form, dot product with RCB in a Cartesian form, dot product because you want to multiply two Cartesian form, which is FCD and RCB, divide by FCD in magnitude form, multiply with RCB in magnitude form. Let's write it right. Theta FCD dot product with RCB, FCD RCB. So just substitute your FCD here and RCB. Where is your RCB? This is your RCB. So just substitute. Okay. So FCD dot product with RCB, you will simply multiply x with x, y with y, and z with z. Remember the dot product formula: 58.8, 0.6, 78.4, 0.4 plus 19.6, 0.2 equal to 7.84 Newton meter. Okay. Okay, so from here, substitute into this equation. So cos theta equal to 7.84 divided by FCD in a scalar magnitude. What is the value? 100. Multiply with RCB in a magnitude value. What is the value? RCB. RCB is 0.75. Sorry, 0.75 meter. Okay. So multiply with 0.75 meter. So theta, you cosine inverse so you will get the theta is 84 degree. Okay, so you get the theta. So using this formula here, formula we just derived back then, so you will get the FCB. The FCB is equal to FCD cos theta. Your FCD is 100, cos theta 84 degree, so it is equal to 10.5 Newton. So this is your force FCB, or projected force FCB. Here is force here, FCB. Okay, that's all.